So, good morning, everyone. Before we start, do you have any questions from the previous lecture? It's live session, so feel free to ask any question or any query before we start. So we are recording now. Okay. If no question, anyone remember where we stopped last class? Okay, let's take a fast review. Let me first share my screen. I think now you can see my screen. So last time we take the water efficiency and energy in the atmosphere. Let's say I have a fast review to what we finished in energy and atmosphere. We take first one is minimum and optimize energy performance. What are the most or the energy use distribution for commercial building for commercial buildings again? And we said space heating or cooling should be the highest. After that, the lighting. The standard we are using is ASHRAE 90.1 2010. If it comes in the exam 2016, no issue. Strategies to reduce energy start from, we call it passive design. We call it passive design. Okay, no problem, Samir. Passive design, even the architect is the first one you know how to save energy, the architect. And this might be new to some of us, but others maybe they have designed based on these concepts like building orientation, glazing on proper directions, shading by trees, where you put the trees, the location of the trees to give the shade in the south, not in the north, and so on. So here you can see and we finish this also. Definition of building envelope, definition of efficiency. This is building envelope. Okay. What is efficiency? Some people think that efficiency that I make green power or I reduce my consumption or I use sunlight. This is not efficiency. This is I using alternative energy source. Instead of opening light, I can open windows if the architect make for me a good window that can make light, enough light for activity indoor. But efficiency is another thing. Efficiency, it's what is the input, what is the output? Mostly related to machine. Remember this come in exams and nobody answer it because the definition of efficiency is not clear to them. Here, this lamp, now the traditional one, if I use LED light, it's more efficient and even better light quality because the input power will give me more lumens, not like the other one, which more input but less lumens. The same for the fan and the other types. We take the controls and sensors. What is the demand ventilation? Take this concept for mechanical engineer. Variable air delivery, not constant air. Okay, this is the concept. Then you can use sensor and control panel to control the amount of air based on the people using the space. Uh, Cogeneration, we said we can use the any system to the maximum. Systems that generate heat like generators. We can also use it for water heating instead of just using liquid to cool it down without any use. We speak about energy model and how energy model is input about the building physical materials and the building physics, or we can call the roofs and every part, and we put what are the, for example, E value or U value for these materials and start to estimate the energy consumption. Of course, the more tight envelope and well-insulated envelope, the less the energy. This is how we speak about Energy Star Portfolio Manager, Energy Star Target Finder, and Energy Star Portfolio Manager. We say Target Finder is very useful for owners in the initial phase of the project. So if you are engineer and you want to estimate, rough estimate of the energy use of the project, you can use Energy Star Target Finder. Very simple tool to help you put some targets to your owners, clients. But if you are facility manager and you need to manage a group of facilities, then you can use Portfolio Manager and they will use Energy Star to report your consumption. HERS, or we call it a Home Efficiency Rating System, just to know it, but it's not our topic. If you achieve 65, it means your efficiency is 35. And then you take quiz. This is Arabic English. I think you have to use the English only. So let me open the slides with English only, because this is not for some areas not written in Arabic. Yes, this one. With the course, I have two versions, Arabic and English. So as per our agreement with STAR, that we will use English language. And okay, after that, we have some concepts about some very interesting concepts about like what we see was here, the energy, renewable energy. And I told you the first thing you need to know, the green power and production and energy production. To the right, green power. To the left, renewable energy production. Can see the screen? Yes. Green power, the one you purchase it. You buy it ready power. You buy it as a real commodity or a real delivery to your building, or you buy it virtually, like you buy just the properties of the green power, a paper. So why should I buy a paper called renewable energy certificate? For many reasons. To offset your emissions on carbons. Some companies have to do that. They have to. Renewable energy production, it means I produce energy on site. Can you hear me clear? Produce energy on site. And there are many ways to do that, like these types of different uses, renewable energy sources. We speak about biomass, geothermal, what is the difference, how we can use the land itself, the earth, to cool or heat our interior space using something called geothermal power generation. Hydropower, of course, this is non-renewable, that we don't need. This is hydropower. How this dam will work based on turbine, generator, and transformer. Turbine, generator, and transformer. Then you will see this in the roads. Okay, simply this turbine, the water will make it revolve. When this revolve between here a big magnet, it will generate power. This power, the transformer will transfer it to I think the frequency that we are using to go or travel through the power lines. Back of the dam, this reservoir, the lake where you keep the water, and this is the intake where you open the gate and close the gate. See this dotted line, control gate. Okay, this penstock, this tunnel, turbine. And here's the flow out of the water to maybe the river, back to the river again. Cool. So we finish renewable energy production and we say green power and carbon offset, which you can buy in open market. It's available and you subscribe for utility provider, let's say SEC, Saudi Electric Company will provide it to you. But it should have condition only to be green E or equivalent certified. So you need to ask them. You make contract with them for 2 years. Of course, it's more than 2 years to contract. You need to, in the real case. But here they say only 2 years because they have many options in USA. But if closed market, what is closed market? It means the market is closed. It means you cannot buy it. It's not available. You still can buy, but you will buy virtual. So you still need to buy the traditional one, like to power your buildings, okay, and business. But you will not really receive a real power. It's just you buy renewable energy certificates or carbon offsets. It has two names, carbon offset or renewable energy certificate, with some difference that carbon offsets allow for building and company to fund activities that decrease carbon emission, remove carbon from the atmosphere. And here the answer, when you ask me, so why I pay and get nothing? No, you will get that you remove. So companies that want to remove emissions from the atmosphere, let's say airlines, they have restriction now for carbon emissions. They want to reduce their emission and they cannot. So they have to invest in equivalent to their emissions in a green or carbon sequestration projects. Okay. Carbon offset projects include reforestation, like what I said, carbon sequestration, energy efficiency, land use changes, like replanting. If you don't understand any of the previous, no issue. As I said, I explained this again here, the power grid. All this we have the last class, okay? All this we had the last class. The grid power here, power grid, so you have green power and you have conventional power. The issue that, as you know, that green power and conventional power, they come to the same grid because we cannot take one grid to green, one grid to power. It's not cost. It's not economic to do that. So all will be mingled and you don't know really which one is green, which is not. From there comes the idea of renewable energy certificates or carbon offsets. This is a certificate that you buy if you want carbon green power, carbon offset, and not that you as a consumer, you pay money, dollars, and you get renewable energy certificate. In here, on the other side, the status will be that you pay dollars, but you get power. So if you do both, see, the more you invest here, the more power will come to you, even here through the grid with a percentage of green is higher. Yeah, because it's open world. Everything is open together. So the more investment in this area, it will come in return in this back to you again, indirect to you or to other consumers. So conventional will be less. The more we invest here, conventional will be less. Unfortunately, still the world is depending on conventional power. More than 80% of the world power is conventional power, or even more. This is REC, renewable energy certificate. You buy it in megawatt hour. Came question in the exam. How you buy or what are the measurement of RECs, megawatt hours, and you buy it by period. See here the period down. You can watch a video about RECs. And then we stopped here, guys. I told you this is a new topic and we need to start the next time for fresh start. So here, this is the start for today's class, the remaining of energy and atmosphere chapter and the chapter material and resources. This for today. For next time, we'll take indoor environmental quality and review questions and answer from your side if you have and so on, or if you don't have, I can give you. So there might be the last class, which is class number 7, will be the next one. Fundamental and enhanced refrigerant management. What are the refrigerants? What means fundamental? What means enhanced? Okay. First of all, we are using in our building some components in refrigeration system, like air condition, let's say refrigerator, if this is very close example to us. Cooling, heating and cooling systems that use liquid. What is this liquid? It's like CFC components. CFC. In Arabic, let's say الفريون. You know الفريون? الفريون اللي بيستعمل في الثلاجات. So, in English, CFCs, chlorofluorocarbons. What is the reason ozone depletion? The main reason or the main cause of ozone depletion, this is components. And these are refrigerants. It causes damage to ozone layer. Also, when ozone layer have damage, the ultraviolet rays will come excessive. Of course, it's good, not bad, but excessive amount of UVs will impact the earth, cause cancer, cause crops damage, animal death, cancers, and so on. So this is very dangerous, even more than carbon, The carbon is another thing, because some people think that ozone depletion is the same as carbon, same cause, same reason, and so on. No, the carbon is different thing. The carbon is the excessive CO2 and the other greenhouse gases, but mostly CO2, 80%, accumulate around the earth. Imagine you are putting a blanket around your body, and then every day you add another new blanket. The same we are doing. We are adding CO2 to the atmosphere, and the more thick this layer, the more heat will be trapped. Yes, yeah, of course. Imagine you put blanket above blanket. The same, this CO2 or gases absorb heat and keep it here. See, it reflect, yes, but it will absorb heat, and these layers already will be heated in addition to Earth itself, where we see the melting the north and south parts of the Earth, Antarctica, and this where the ice melting, changing in the weather, climate change, climate risk, and so on. From there, it comes all this from this simple concept. So before we know about climate risk, climate change, become a specialist, you need to know the simple concepts such as these concepts. So in refrigerant, we need to reduce this component for both reasons, to reduce greenhouse gases and reduce ozone depletion. So you can use the natural refrigerant instead of CFCs. CFCs, chlorofluorocarbons, damage the atmosphere, so we need to use natural refrigerant. Natural refrigerants such as water, you can use it, ammonia, NH3, carbon, carbon dioxide, hydrocarbons, and the air. This we call it natural refrigerant. Air, CO2, H2O, ammonia, and the hydrocarbons. like propane, butane. They are good for environment. Okay, but they have this advantage that these are poor refrigerant properties. Of course, if you use CFCs, it's better than this refrigerant because CFCs is very يعني volatile. It can evaporate, condense, so very easy. But it's not like water and others. Uh, so this is advantage, but the disadvantage is big because if you use CFC, it will cause ozone depletion. We can manage that these are not efficient. This we call it natural refrigerant. What does it mean not efficient? It means you use more power because to evaporate something like water or hydrocarbons, it's more than it takes energy more than CFC. It means more greenhouse gas. And from here, the trick you need to know that I have ozone depletion taking priority over the greenhouse gas. Something kill better than something, or we need to avoid something that kill or destroy the earth. Chlorofluorocarbons, this is the CFC. We said excellent refrigerant properties. Very high ozone depleting potential. This is the problem. This is the problem. It's now not used in USA, by the way. If you buy a refrigerator or any air condition using CFCs, it's not existing anywhere from USA and Europe, even China. It's completely phased out 2010, so since more than 13 years, no CFCs now. So some people, some one of my friends say, I have a refrigerator in my home, old one, using CFCs, still working, like very nice. So yes, it's good properties, but the leakage can cause damage to ozone. But remember, guys, it will not kill us, the CFC itself, because it come in the exam that leakage of CFC and so on. So people, yes, no CFCs, it will kill. No, it will not kill the CFC. The CFC will go to the atmosphere and make ozone depletion. That would kill or cause many issues, okay? But CFC leakage, no problem. If you have refrigerator and have leakage in your home, you will not die from the CFC. Hydrochlorofluorocarbons. If you notice that we added H only, so it's almost the same effect of CFC, but little bit less. Both are not good. Reduced chlorine in this compound, and it is also it will also be phased out by 2030. So still only around 7 years, 6 years to phase it out totally. Most of factories now starting not to produce HCFC. It has the same impact. Example are 22 or 123. So what to use then? What to use? There are something without chlorine. You notice HFC, hydrofluorocarbon. There is no hydrochloro here in the back again. Chlorofluorocarbon. Hydrochlorofluorocarbon. So I believe the problem is in the chlor. The chlor. So here HFC is with types R134A, 407C, 410A. Try to remember these guys as much as you can. Sometimes they ask in the exam this. So HFC, zero chlorine, zero ODB. Excellent. So it will not impact ozone. That is the kill point, like the point that you make it, you choose it. After that, it may be higher global warming because it's not efficient like CFC. Okay, but it's not natural refrigerant, by the way. It's not a natural refrigerant. Energy inefficient compared to CFC and HCFC. Yes, I know, but we use it because it's zero ODP. So now, let me summarize all. This schedule will summarize all. I will ask many questions. What is the worst refrigerant first? You will answer me the worst refrigerants are CFCs. HFCs. Okay, I want to make this color is let's say green better. So this one is CFC 11, CFC 12, 114, 500, 502. As you notice, ODP off. So this is blocking issues. No, no. Even GWP, you will find it sometimes less than others, but it's higher, by the way. So this is the answer. But the worst refrigerant is CFC. Regardless the number here, but all CFCs. What is the best refrigerant? Okay, someone can answer me in the chat box. What is the best refrigerant? I will tell you. You know what's the best refrigerant? HFC? No, no. HFC here, yes. Hydrofluorocarbon here. This is HFC, right, as you can notice. But it's not the best. The best refrigerant is natural refrigerants. We speak in the first slide, like carbon dioxide, ammonia, CO2 or CO2, ammonia, hydrocarbon like methane, propane, and so on. Remember it? So this is the best, this is the best, this is the best, this is the worst. What is the second worst? So in the second degree worst. Yeah, number one bad, number two less bad, but it's also the same. Remember, CFC, chlorofluorocarbon, hydrochlorofluorocarbon. This is the second refrigerant. So this is the second question. Exam questions, huh? I give you now 5 questions. Exam will come from them. HCFC. HCFCs, 22 or 123. Remember these numbers. These are simple. No need to. This one, the most famous is 11 and 12. And 114. Here, 22, 123. As you notice, it has ODB, as you can see. This is ODB. I mark here GWB. I mean here ODB. So ODB, this is blocking. No. That's why it will banned by what? Anyone remember the year? It will be banned by
2030.
Excellent. Based on what? Based on Montreal Protocol or Agreement. Montreal. The governments of the world make a committee in the Montreal in Canada, and they signed the treaty or agreement that we will ban these components by 2030. And the CFCs banned by 20 what?
2010.
2010 by Montreal Protocol also. This is the so how many exam questions here you see it will be asked 3 or 4. Hydrochlorofluorocarbon or HFCs are not banned. Mostly they are used in most of refrigerants based on different types of these. Don't know exactly which one, but maybe 407C, this is very common, or 404A, this is very, very well used because it has all 0 ODP. So this is okay. Now I can listen to you. But you will notice, and this exam trick, the GWP even higher. See, 12. I don't see even 12 here. So you try to optimize these components and getting the lowest global warming, but you cannot avoid anyway in HFCs. The natural refrigerant are 0 also, ODP. ODP means ozone depletion potential. The amount of impact they will impact the ozone layer. Global warming potential. GWP means the amount of global warming caused by this component, like the CO2 emissions and the impact. So their global warming potential are high, these all. Here also global warming are high. Why? Because to make refrigerant to the same amount, you need to take either more time for this or more energy. So got it? This is the But actually, I will tell you what is the best refrigerant in the next slide. Try to remember this schedule, very important. It will come some questions in the exam. I want to okay. So the best refrigerants are natural refrigerant. Actually, no, there is best. Architects can do. Architects can do. Architects can do what? Can do open windows if possible. The number one. No refrigerant at all or natural ventilation is the best option. It comes before using natural refrigerant. Okay, so architects have very big responsibility to implement this concept and to make the others, because he is the main or the maestro of the building who put all this. So we need to know when he put windows, what does it mean? When he make natural ventilation, what does it mean? Not making the building is glass without all artificial ventilation or depend on the ducts and equipment only. So many times you find the weather is very nice, but you cannot open windows because the architect did not put the option of having windows within your building. All what we have discussed now to come to here to this slide, it was just a background, but it's a part of the exam, as I told you, everything you need to study. Because in here, what are we know what is RCFCs, HFC, global warming, ozone depletion, all this. But in here, we need to know what is the relationship to LEED. What is the problem with LEED? What are LEED requirements? So we know first what they are, and then what are the LEED. So the LEED for new building, no CFCs, it's a prerequisites. A prerequisites in LEED BD plus C or in LEED all LEED. For major renovation, no CFCs also, or major renovation, suppose I have systems that use CFC. So if I have major renovation, I need to phase out the CFC before completion of the project, since it is a major renovation. So new buildings and major, why? Because I told you before that major renovation include envelope, changing envelope, changing equipment, mechanical equipment, HVAC, ducts. So it means you will change them. So you have to change equipment. It's a major renovation. You need to phase it out. No other option. In the new building, you don't need to use it from the start. Zero CFCs. But in the existing building, there is a way. You make existing building operation and maintenance LEED O plus M. There is a way here where you can have first option is no CFC or phase out within 5 years. This is an option. But if not possible, like you have reason, it's not economic, the building life cycle or the building in the middle age or in the last quarter. So it's not economic. You just need to prove in this case that replacement of CFCs are commercially not feasible. And you guarantee that the leakage are reduced based to 5% or less using what standard? Using EPA Clean Air Act procedures. So you need to remember this information here. You use Clean Air Act procedures to verify that the leakage is less than 500. If it's more, you make the required to make it less than 5% a year. And as I told you, the trick here is that leakage is not an issue. People will not die if there is a leakage 5%. Okay. Here are the LEED requirement, guys. Okay, for the refrigerant management. For the fundamental always is a prerequisite, so it's a must. The previous slide, this one is a must. And this summarizes all the LEED requirements. Very simple, huh? For enhanced, it's just additional reduce overall impact caused by refrigerants. Select refrigerant which have less ODP and GWP. Select equipment that can operate at low pressure, because the lower pressure, that the less the leakage. Next is reduce leakage. Select equipment with higher life, of course. I will go to the last one. No halons. Halons, CFC and HCFC. So will tell me, okay, why you don't tell me about halons? You tell about CFC and HCFC. Halons used in fire suppression system, and it have the same properties like CFC. So it also have ozone depletion. These are the halons. Okay. Some powder or something, when have fire, you open this fire extinguisher and you distribute this. Any question for the refrigerant management? Okay, good. So that was refrigerant management. It was a credit and prerequisite, fundamental and enhanced. Now we'll move to commissioning. Also, it is both fundamental, which is prerequisite, enhanced, which is accredited. Commissioning is a new topic, huh? We finished the previous one. So commissioning. Mostly for architects who are not so familiar with commissioning or write CX or CXX, this is the. But we hear about it for sure, especially if you work with contractor before, consultant. So you will hear commission. Commissioning is a word that indicate verification and documentation. So a process include verification and documentation that building and all its systems plan, design, install, tested, operated as per OPR, owner project requirement. So mostly sometimes you bring third party to do the commissioning in addition to the project team, of course. Because this is critical. It's about handing over process, testing, and commissioning. But in LEED, it have some small different of views, like fundamental and enhanced. And don't think that the scope of commissioning LEED is bigger than the project commissioning. No, it's part of it, but you need to have to know but just the tricks of it or some parts of it, or the names, the definitions, and so. Fundamental commissioning in LEED, start late and end early. What? Start late meaning in construction phase. Okay, or by the end of construction phase. But enhanced commissioning start early in the design phase. Before you conclude the design, you should have started commissioning, enhanced commissioning. So it makes a big difference. So pre-design, design, construction, building, construction, testing, occupancy, operation. When I say fundamental, always you start the fundamental during the construction phase and so on, but during the design, this is enhanced commission. Why? We LEED want to start early commissioning to put the commissioning requirement within the design documents. So I design it, I will tell you how to test it, what is required. I put this within the documents, which is better results. Why commissioning? Ensure energy systems are designed and maintained as per OPR. What is OPR? Owner project requirement. Commissioning reduce maintenance? Yes. Why? Imagine you finish some work and you have a lot, you want to make testing and commissioning. When I was making website for my LEEDtricks green buildings, the developer of this give me the website. But if I want to add any word, I was find issue. I cannot, this is not working, this is working. So I remained 6 months modifying and issuing instruction to him, give this, fix this, correct this. So commissioning, imagine that your owner take your building without all this testing. What will happen? It will be a problem for you. Another question, exam question, what are systems to be commissioned? Someone will tell me, fire alarm, it must be commissioned. What system? Cooling and heating towers. It must be commissioned. Okay, from your opinion, I'm speaking from LEED opinion. What are the systems in accordance to LEED must be commissioned? Commissioning scope is big. Commission any system you want. I tell you here in LEED what system to be commissioned means what you will do commissioning for what systems in LEED. Okay. So HVAC equipment and associated controls and sensors and so on. Lighting and daylighting. Lighting and daylighting controls. Daylighting controls, which is sensors. Lighting the light. Interior lighting. Lighting equipment and so on. Domestic hot or cold water system. Renewable energy systems like wind and solar and so on. Envelope commissioning, it's additional and it's another option, but it's included also within if you want to do it. 1, 2, 3, 4, 5. In the exam, he will make you confused. Fire alarm system. It's not mentioned here in LEED. So it will be done during commissioning of the project, but not required by LEED commissioning. That was the commissioning, guys. We don't need to deep further in 100 page in the LEED PD plus C. Yes, they are 100 pages, give you more details. In LEED GA, this only required to know about commissioning. So hopefully if we have LEED PD plus C course after you pass this first examination, then we can have further discussion on commissioning. LEED in general will enhance our level in understanding our scopes more, doing it more efficiently. It's not about to be a LEED coordinator or LEED sustainability, to be specialist, no. Maybe some of you will be, yes, but 90% or 80%, you will do your work more efficiently. You will have more holistic approach to your design. You will have many considerations and so on. The next credit here is building level and advanced metering. This is a credit, okay? And the prerequisite. What is building level and what is advanced? Both are metering. What is building level metering and advanced metering? Okay, here, building level metering. This is the name of the credit, okay? Advanced metering. Building level is fundamental. It is a prerequisite. Like what? Like I have in my apartment 1 meter to pay my electricity bill. It is building level. Or I am the owner of a building that I have 1 meter to measure the electricity bill. I pay this power to the government. Okay, so it's a metering, but it's kind of general metering. Huh? Okay. Advanced metering is a credit. It's not a prerequisite. And in here, where LEED, you can earn some points. So here, advanced metering. So it's not here the reason for paying bills, but to make more control over the systems like energy and also water later. But here we speak about only energy. So advanced metering system, it will provide end-use energy distribution metering. Okay. Let me say, okay, I want this zone to be metered alone, that zone. Or I want lighting to be metered with 1 meter, all lighting system. And I want the energy system, HVAC, heating and cooling systems, to be metered alone. Okay? And I want other process loads to be metered alone. Why? When I meter lighting, so I have control over the lighting. I know how much lighting consume. Not mix everything in one, so I don't know which system is using more energy. In this case, I can make decision, for example, okay, lighting is more, so I will change all my lighting system to use LED lights. My HVAC, I need to change because it's not efficient. It has leakage and consume more energy, so I will change it. So it's the energy metering itself, it will not save energy, but it will help you take decisions to save power based on information you get from the metering, the meters. It also advantage leakage in case of water, or leakage here also if there is any system deficiency of, or system consuming more power, I can take decision to replace it. Very simple, credit only this slide, but have the information to understand. In LEED AP will tell you how many system, what are the system. Of course, not every system, like water, you remember 80%. Yes, here also the most important system, you can do advanced metering. We had this issue in a stadium project, and the stadium have many zones, and every zone is independent. They connect or lighting, HVAC, everything in one zone together by meter. So they said you cannot do meters for the system in studio because we'll multiply every zone, and instead of 1 meter for every zone. So every zone will have 4 or 5 meters by how many zones? So we'll have around big number of meters. That's why some buildings will have issue with this based on our experience with special stadiums. But we still can do something with that. Yani. The designers should put an eye, electrical designers and power designing, to put segregation of the systems, classify the systems by use, like power or this lighting, at minimum 2-3 main systems. We make separate meters, how to connect it, check the technology regardless the building type. Some buildings will be difficult, but yes, it's not a prerequisite anyway. It's advanced metering is a credit, but it's required, especially if you work in Mustadam. It will be a big problem to you. Demand response, another credit. Any question first for metering? For the lead study here is easy, but I'm just telling you the problem in real life, their project. If you have here electrical engineer, will tell us if we design the power lighting for stadium, it's difficult to do. Yes, sometimes. Demand response. Demand means energy demand. Response means, okay, let's see what is the response. You know, power consumption during the day or during the seasons are not equal. Of course, the peak hours during the day or the summer seasons during the year will have higher consumption, especially in Middle East. So electricity demand is not uniform through the year. Peak demand occurs at extreme weather condition, very hot or very cold, so I need heat or I need cool. Utility companies like Saudi Electric Company, for example, need to have generation capacity and the grid infrastructure to meet the peak demand. So when I have the big demand here, maybe all my generators will work. Yes? So at peak time, generation plants will have to run full load. Imagine you are working full loads, it means your full power, many faults can happen. Okay? And especially if you have inefficient power plants, they will also may stop or may consume energy. To consume will be more because you work full capacity. We agree that as a concept or a common thing that any system, when you use it, you're not using it 100%. You need to load it only 70% of its power maximum. Okay. Why? Because if you load it 100%, it will not work as required. So demand response, developing generation, transmission, and distribution infrastructure is called site management. This kind of response, like what? I'm selling a product. The more people need the product, the more I produce. But actually, the problem that the product here is power. So the more people need power, the more greenhouse gas. Yeah? So we call this generation and we call it supply side management. The more they need, the more I produce. But actually, I don't want to do supply management. I want to make demand management. The more people need my product, I will raise the price. So I am producing the same, but I am raising the price. So I'm reducing people demand. People who don't really need it will not pay for it. That's why this credit name demand management. Demand, the credit name, demand response or demand management. Okay? Demand side management, we manage it. We will not let people also suffer, but let the people use more economic and distribute their work. Some Europe and some areas, they will give in some cities a proper time to wash, like at night, evening, not during the peak hours where there is very cold or very hot and so on. So because there are air condition load and so demand side management is much more economical compared to developing infrastructure. This just to need to know the concept here, the background. What is demand side management? What is supply side management? So إدارة العرض وإدارة الطلب in Arabic, okay? So demand side strategies in lead. So I want to manage their demand, reduce demand. So I will work in lead in what? In supply management or in demand management? In demand management. In lead, I will work in demand management. Why? To reduce people demand. So DSM strategy, demand side management strategy. Higher demand charge, like what I told you. Thermal storage, like, of course, at night there is no demand on power, but the power is there. So why I don't make it storage? Chillers with thermal storage system run at off-peak hours, store thermal energy, or thermal storage system, store thermal energy, and then use it during the peak hours. Okay. Another way is demand response. Okay. We speak demand side management. What is demand response? This is a lead way, the lead way to manage it also, to reduce the demand, which is the credit name. We'll explain it in the next slide better. This, there is some, 1 second. Let's wait. Sorry. Yeah, this slide. See, it was here, and then this one, I'll explain it in here. So the lead credit, we call it demand response. How lead manage the demand based on the information we had? I'll tell you. During the day hours, the peak hours start at some point, like at 2 o'clock in the afternoon, starting 100% of air condition started to work from 12 to 2. And here we call it that trigger point. The utility or the utility means the Audi electric company, for example, notice that the load is starting to come high. If they leave it, it should go like this during the day and then come down at night. So the trigger point here, the point that you should take action to reduce the demand. What they will do, the utility company will send a note by mobile, by SMS to facility manager, to building owners, to the one who have registered the meter of the building. Send him. Peak hour started. Peak hours started. Yes, you need to know. So the users will know that, okay, the kilowatt hour now is 10 reals instead of 1 real. So, okay, let me close this light. I don't need it. It's already daylight. Let me turn off the TV. I don't need to watch TV now. Let me turn off the washing. Make it, let's wash at night better. Okay. Employees, okay, open the window. You have the big view to the sky view or skylight or window. Let's use the window, open the curtains. Something like that, guys. Okay. So anyway, you find the load is reduced. In here, again, they will send a signal that, okay, peak hours finished. Okay. As you note, why we do demand response? For the benefit of who? If someone tell me, this will be good. I will tell you. Demand response for the benefit of utility provider, SCCY, because if have limited power production, it's not open. So when they fully produce power, it will be a big load on them, and the miss or the loss it would be high. So the first instance or the only credit in LEED system, that is not for the benefit only of building, but for the benefit of the utility provider is demand response. Because it is based on cooperation between building facility managers and the utility or power provider. Clear? So the project should have, of course, a software at the right and hardware to participate in demand response. Issues here that your SEC or provider don't have this technology to send signals and so on. In this case, you need to have the software ready and the infrastructure like control room for something that control all systems, or automation system like what we say, to be ready. So when the utility have this facility working, then you can participate. So if you even you don't really apply it in real, but you are ready for it, you will get 1 point of the 2. Okay, and the project should participate in demand response if it's available. Okay, cool. This is a summary what we have in this chapter. Fundamental commissioning, minimum optimized energy performance, metering, refrigerant management, demand response, renewable energy production, green power, and carbon offsets that we have in the study. What is green power? What's carbon offset? We will have some questions and answer like what we used to do, and after that take break and then come back here to again work in the next chapter. Energy and atmosphere questions. Rina. I received your questions. Good. There is better improvement the responses. So this is good actually. And the more you study my material, the more you will enjoy it. The more you listen to the chapter and the course and so on. We have 18 means we will answer 9 questions to you, and you will answer 9 as homework. Question number 2. In the typical United States commercial building, number 1, sorry, which use consumes the most energy? We said space heating.
Doctor?
أيوة.
Sorry, but your slide not appear here.
Oh, okay. Good, you tell me. Thank you.
Good.
Yeah, these are the question again, and chapter 6, energy and atmosphere. In the typical United States commercial building, which end use consume the most energy. يعني في داخل المبنى inside the buildings. Sorry for the. I mean inside the buildings. What consume more? He measured in US. So he said in US in the space heating, but if in our country it will be the cooling, for example. But he say here in US, so space heating. Using passive. Okay, passive is very good in all architects now. The more you design with passive design, the more you save energy. The good architect is the architect who do passive as much as he can reduce energy by 20, 30, 40. In Europe, there is a system, we call it like LEED also, but they call it passive design. Most architects take this course. How to design the envelope with good insulation, the orientation, how to put the sun blocks or the sun shades, All these very important actually skills. If you are architect, you need to really go and take course or develop yourself more in these studies of physical properties of buildings and dynamics of the building, how the shape can impact the energy, how the shape of the building can impact the energy. Using passive strategies such as daylight is an example of which of the following. Daylight means the natural light, the sunlight. So I'm using passive, I'm using daylight. This example of reducing energy demand, energy performance management, increasing energy efficiency, renewable energy practice. So it's reducing energy demand. Why? Yes. Let me answer. Yes, reducing demand. Now you understand very well the difference between, because before, if I don't explain, you will tell me efficiency. No, it's not efficiency. Okay, it's not also renewable energy, because I was just using what? Open the window. Renewable energy means production of energy. Energy performance, I told you performance and efficiency or performance management, it's about machine. I use input and output. Yeah. So P and C are the same. So now you answer it. I'm happy that you answer it right. Reducing energy demand. Reducing demand. It's not efficiency. Question number 5. Some people really finish LEED PD plus C and they don't know the difference between energy demand and energy efficiency. Really, I promise you. And they pass the exam. Which of the following is a benefit of building owner choosing install wind turbine? Wind turbine. Wind turbine. It means on-site what? On-site renewable energy. To reduce the building grid source renewable energy use. Of grid source non-renewable energy. So I do install or power generation on site to reduce greenhouse gas emission, to lower liabilities, to heat island, to decrease upfront building cost. Of course, yes. Excellent. Thank you. Number 7, increasing the thermal mass. I would say very good today, actually. Thank you. Engineer Ahmed Wahba, number 7, please. Or Engineer Anwar Jude, if you want to answer. Number 7, you can read and give answer.
Increasing the thermal mass of building and installing a photovoltaic system would help with renewable energy, reduce energy demand, photovoltaic system, increasing energy efficiency and reducing energy demand, renewable energy and increasing energy efficiency. COD, it's the same, right? No, the increasing and decreasing. Renewable energy and decreasing. Maybe I will go with D. Renewable energy and increasing energy efficiency.
See,
C, yes. Not D,
increasing
not decreasing.
thermal mass, thermal mass, this is the wall thickness. The more you add thick to the wall, yeah, like you see in old
Okay.
building, big wall, this we call it thermal mass. The more you add mass, the more you add insulation. Before, no technologies, so they use mass.
Yes.
The block wall is very high, very wet. Even now is also very effective. So thermal mass is a kind of passive design, right?
Okay.
Of a building. And installing photovoltaic means renewable energy. Okay. Would help with renewable energy. Thermal mass is renewable energy. Photovoltaic renewable energy.
No, photovoltaic renewable.
Okay. Renewable energy, photovoltaic. Reducing energy demand is
With thermal mass, yes.
Thermal.
With the
Increasing
isolate.
energy efficiency. No. Right?
No.
We speak about
Yes.
efficiency. So to B and C, no. Even D, you see efficiency, yeah?
Yes. So
So
we will not
We are not here. So if you remember again the one I told you, the difference between efficiency and demand and the demand.
Reducing energy demand.
Yeah. So as architect, you can reduce the demand.
Yes.
So the answer is interesting. And as you can see, the questions need someone to understand before you remember. Which of the following is reduced with the help of carbon offset? Carbon offset will reduce what in easy way? Which of the following is reduced with the help of carbon offset? CFCs, ozone, water contamination, greenhouse gas emission, of course. Yeah. It's not really like reduced absolute reduction, but I mean like equivalent. We add equivalent, like you do good, you do bad, so make it equivalent. So equivalent to greenhouse gases, you make carbon offsets. 11. Let's say engineer Islamuddin. Say D. D. What environmental benefit of purchasing off-site renewable energy, meaning green power? And I told you on-site, off-site, and so on, green power, and you become master of this. Emission reduction, stability, electricity blackout, reduced environmental regulation. Of course, it is emission reduction. Yes. Yeah, that's right. Number 13, which of the following refrigerants are banned or scheduled to be banned under the Montreal Protocol? And choose two. Can you guys answer? I will open chat box. You can see your answers. Okay, excellent. I can see good, which is CFCs and HCFCs. HCFC, not HFC, of course. CFC banned by 2010, HCFC will be banned by 2030 based on Montreal Protocol. So the answer is B and C. Sorry. Or C and B, no issue, also correct. Next one is commissioning. So it's about commissioning credit in fundamental and enhanced. Commissioning of building is intended to verify the building and system meet which of the following? Do you remember? The meet the exactly the owner project requirements. Yes, C. Yeah, that's right. Number 17, which is the last, I think. Yes. I want to answer number 17. Choose two. Let's enter it. I open the chat box. You can see what LEED credits reward the project for improving operational performance. Imagine here LEED credits, and they say also choose two, huh? So you need to choose two. So you need to choose two answers. This first thing you need to know about this question. Credits that are related to operation or improve the operational energy performance. What is it? Is it commissioning, energy metering, green power and carbon offset, demand response? So the credits that reward will give you points when you project improve the operational energy performance. Here about performance, about efficiency and performance. Commissioning or metering. Metering will help you, of course, take the metering and take decisions and so on. But why not the demand response? Yeah, because this credit, if you implement it, it's totally operation. Demand response, people will take action to make more, reduce the loads. Okay, so they will reduce the loads during the. But he speak here about more about performance. So maybe it's not the case. Commissioning. Commissioning, I would say yes. Why? Because commissioning, you test the system to make sure it's work in a proper way. The input, the efficiency, the everything is good. So when I do commissioning, it will improve operations of the building. Green power and carbon offsets, it's not efficiency. It is a alternative or offsetting. It's not. So green power and carbon offset is not with us. So I will choose between A, B, and D. Commissioning, energy metering, and demand response. So commissioning and energy metering are very good ways to improve operational energy performance by doing commissioning and by metering. So you can take good decisions to what to in the right time, or when is the metering, or you have more controls in the systems and you meter and you know what the consumption of these systems, then you do energy efficiency better. You take decision of changing the lighting type and so on, and same for commissioning. I would not choose demand response. Why? Because demand response is kind of offsetting load, or in electric engineering you call it load shedding. So I avoid the use of the system for some times. It's not about I make the system more efficient. You get the point? You need to deep thinking in it. So demand response, I just let's say I turn off the light, but it's not like that, of course. But I said, oh, okay, it's peak time now. Okay, let me turn off the lights. Did I do any efficiency, guys? If I turn off the light? No, I do here what? I reduce demand. But in commissioning, it gives me efficiency because I make sure the system inputs and outputs, the metering. I make sure that the metering in a proper range. If any leakage or happen something in the system itself, so the machine is working in proper way. So commissioning, energy metering. Remember it. This question, even you answer it correct or wrong or half, if you answer one correct, you get 50% of the points, like 1 out of 2. If you answer two, you get 2 points. Okay, so commissioning, energy, metering. Some questions we learn from it really, so it needs thinking. I think it was good to meet you, and yes, correct, A and B. And yeah, any question before we go for prayer and break?
Sure. Regarding question number 7.
Go ahead, please.
Yes, regarding question number 7.
7. Okay, 7. Okay, let's back to 7. Yes.
You're told that the answer is C. Can I know the difference between C and B? Why not B?
Increasing the thermal mass of building and installing photovoltaic system would help with renewable energy and reducing energy demand. No, I didn't say C. I say A.
B.
I say A because I say this is efficiency. B, read the word efficiency. Efficiency. C, efficiency. D, efficiency. A, when I increase the thermal mass, I make what? I reduce. So I reduce what? Demand. right? Photovoltaic renewable energy, we know, خلاص. This is no issue for that. Even he put it everywhere. The issue he asking you in this question, what is efficiency? He wants to know from you that you know what is the difference between efficiency and demand reduction or reducing demand. Yes. I think if machine, this is energy efficiency, input and output. So increasing energy efficiency is not by adding thermal mass. I put the wall thick or I make the envelope very good to avoid using extra energy in general. But if I want to say efficiency, so I will say that the LED light is more efficient than the normal light, consent, the old light system. Yes? Why? Why LED light more efficient? Because input power is less and the same lighting or better will be produced. This is efficiency. You are more efficient because you finish the same work in less time. Yeah? But when I say, okay, I have 2 efficient employees, so I will remove non-efficient. This I will make what? I reduce demand. Okay, so I will not use other employees. I reduce demand. I open the window for the sunlight instead of lighting. Does this change the efficiency of lighting I have? No, it just reduce the demand on the light I have. Clear? So thermal mass, I make the wall thick. I make the wall thick. So instead of open air condition too much, maybe in sometimes I will, because the wall is very good insulation, like old building, it's like air condition. So instead of making the air condition running. Oh, okay, I always, my building is very well insulated. So the walls help me to avoid or to reduce demand on air condition. But the air condition efficiency is another thing. It's about what power you consume, what cooling they produce, cooling in horsepower or whatever. Okay? Or BTUs, you call it thermal units. Clear, engineer? So the answer here is A.
Yes. Yes, okay.
Okay, thank you very much. I will see you after in half hour. 12:30. We'll see you then 1. Good. So have a good break. And we'll back 1 o'clock sharp. Thank you. السلام عليكم ورحمة الله. أهلا بكم في الجزء الثاني لقاء النهاردة. الشابتر اللي جاي هيتكلم عن material and resource. Okay, let's speak English the same. So the next part or the second part of today's lecture is about yes, sure, Islamuddin. I just say hello everyone. The next part of our lecture will be the introduction to materials and resources. Okay. These are the credits and prerequisites we will discuss. But before we go to the chapter, as we used to, we will do some background. And this is also part of the course. It's not additional source. It's part of the course to know some useful terminology that we'll use in LEED. Embodied energy. Embodied energy of the product is the total energy consumed in extracting, processing, manufacturing, transporting, and using material or product. So embodied energy is the material you spend through the life cycle of the product. Clear? Very important when you do life cycle assessment or analysis. When you do life cycle analysis, embodied energy is one of the basic concepts you need to know. We will not do life cycle analysis in LEED. It's a separate course. If you do LCA, there are many resources. You can communicate with me, and I will tell you what are the resources where you can go, or what are the trusted companies they give. I don't give LCA. I will send you a group link at the end of the course. This is additional. It's like not a part of your course here or agreement, but this is my own group. I support all green buildings engineer who are willing to take the exam through a free group, free of charge, where we answer questions, we have communication, we have many topics to discuss, how to register exam, and so on. All these topics in LEED Media Group. I will remind me to send the link before the end of the of our meeting, or just I will tell you something very easy. I will write here in the chat box. This all my social media links. So link tr.ee/LEEDtricks. I think this is right. Yes. In this link, one second, to all of you, sir. And this link is that you can see all Linktree. You will open, when you open, you'll find website, LEED groups, Facebook, social media, where many valuable information I put there actually, and it's all for free. Remember to make membership in LEED Media Group. It's a free group. Support all green building learners and LEED learners. Okay? It's part of it. Once you open the link, you will see it. It's the last one, the last link. Okay, that is the one. Got it? Link 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 this one word .ee/LEEDtricks. You will find all my links. Okay, back to the embodied energy. Embodied energy and life cycle analysis. Again, life cycle is not part of our course. It is calculated based on some phases, like you call cradle to gate. What is cradle to gate? Gate of manufacturing. From extraction to the gate of the factory. They calculated also cradle to site, when it reach to transport final product to your site. Engineer Muhammad saying something. Yes, Engineer Muhammad, here you just click. One second. Click any of these links. Where? Yeah, when you link this LEED Media Group, the last one, it will open. Click it, you make membership. This is free group. This social media, my social media, including YouTube. I put, for example, how to register for the exam. Any questions from people. I have weekly, when you make membership in this group, LEED Media Group, I have weekly meeting every Friday at 4:30, free meeting, no payment. 4:30 to 5:30, where I answer any question about green building on Earth, like not only LEED, any question about sustainability and green building I answer, but with focus in LEED and LEED rating system in this group, LEED Media Group. Every Friday. Of course, some people take with me course, my site, but this group is open for all. This social media, YouTube, very important, because in YouTube, I put something you need, like when I find people need how to register for the exam. So I'm making video now. I put it in YouTube, how to register. This, of course, we cannot explain to you here in the course, because the course is limited time. And there are many issues you will face when you book the exam, when you study, and so on. So you will not really be able to. So I give you continuous support up to passing the exam. Up to passing the exam. Website also. Where website? The first one is my website. But this website, what I explain and I give you here, it's in the website. Only the additional there is the practice simulation question. This you can buy. and maybe if someone need from you, I will give you very good like coupon discount for only DAR members, inshallah. Okay, but this last step before the exam. Course also for Arabic speakers, you can find the complete course there in LEEDtricks website with in Arabic. Okay, let's back to the so this cradle to site again. Embodied energy or cradle to grave. What is cradle to grave? This is what we mean here or what we focus in LEED. The embodied energy from the extraction until demolition of the building. How much energy, how the energy you will spend. But all this one concept, we call it embodied energy. And they are all end up with demolition, with waste. But we don't want that. Again, we are in the concept part of the material chapter. We want what? We want cradle to cradle. What is the cradle? Cradle is a baby car, I think. Yes. But cradle here means from the start, from the initial phase. Cradle to cradle approach, meaning before we just think to throw this or send to landfill means send to waste. Yeah. Before we think of that, no, send it to factory to make it another cycle of the product. So I have wooden chair, after that become wooden board, and I put it in my decoration or wall or insulation. Always the material go in closed cycle like what we see. So conventional product have cradle to grave. No, we don't want that. Cradle to cradle product are environmentally preferred. We always think in our design and construction how to think after this design, where the material will go, like Qatar when they make World Cup in 2022, they think that some stadiums they will dismantle and they send to some other developed country to make some other building types. Life cycle assessment. When I do life cycle assessment, I want to do it to determine what are the environmental impacts of a product, process, or service through production, usage, and disposal. Okay, life cycle analysis or assessment, the same words are the same. We can say assessment or analysis, no issue. It assess what? Global warming potential. How much material have impact on global warming? Depletion of resource of ozone. What is the impact of this material in ozone? Impact on acidification of water, eutrophication that we take before, formation of tropospheric ozone, depletion of non-renewable energy source. Have you seen it before? Yes, you have seen it before. You know, when supplier bring you data sheet and building product information, some suppliers will put this information. The one you see here in the left. Some suppliers which have awareness of this, they will put this information. The impact and measure primary energy consumed, global warming potential, ozone depletion, acidification, eutrophication, creation of smoke, and so on. They will put information as you can see here. This we call it LCA impact categories. So don't confuse it with LEED categories. This is just about LCA. When I do LCA, these are the impact categories, 6 categories. My advice, remember them. My advice for now in LEED only require for you to remember them and to know that these categories are categories of LCA. That's all for now. In LEED AP, we will have more work in this area, but not too much, only another 2-3 slides. Okay, so remember these categories. That will be enough for LEED exam. So in material and resource in general, this is the waste at the start of our production of the waste. We will do some processes to reduce this waste, like reduce first and always in LEED. The first thing is not to go and make reuse or recycle. No, the first thing always is to reduce. This is a key word of the exam. Reduce is the first thing to do. For example, energy. The first thing I make renewable energy, I do energy green power. Okay, that's fine. Okay, but before you do renewable energy, reduce your energy use. Reduce your demand. First thing, reduce. I will recycle water. I will use the water from rain. Okay, good. But first reduce your water use. Again, so see, this is the concept. So always reduce. Exam concept, put it in your mind. That first thing to reduce. After that, do your all technologies. Reuse, recycle, recover. Then send to disposal. When you do all this, the disposal will be this small one. Very small. Good. So most desirable or less desirable. The most desirable is to reduce, reuse, and so on. And as you can see, this cone is going down for the waste. So waste reduction includes all these ways to reduce waste and use environmentally preferable material that have many measurements like reducing GHG and so on. Now we'll move to the chapter itself. Just give me a minute, some noise. So the first and credit and prerequisite, sorry, storage of recyclable materials. We are in material and resource. This chapter about material, about waste. Okay. So the intent or the requirement here to facilitate recycling. How to facilitate recycle? You must arrange your design to include a space to use for material recycling. Otherwise, where people will put the recyclable material? You need to put books like very famous, and you all know it for different types of waste. Like that's what you see here, and you write the what are the components you put here, and there. Okay. So provide dedicated storage facility. Who will provide? The designers for recycling. What to be recycled? You need to put storage for paper and cardboard and glass, plastic, metal. Five. Every one of these guys, we call it waste stream. Waste stream. Let's speak now waste. Waste stream. So recycle, paper, cardboard, glass. If I say glass, this is a waste stream. Stream of the type of glass. Waste stream, plastic. Paper, cardboard, glass, plastic, and metals. Okay. After that, decide on the type of recycle, commingled or segregated. You know that some people, beside in organic waste not included, like food waste. Okay, organic waste not included. We speak about this. Sometimes in some companies or area, they put only one box. We call it commingled. Commingled here. See, commingled recycle. You'll put three box. No, one box, big box only, and all people will throw all these types of waste, five waste, in this box. But this box, if you do this way, you will get the prerequisite, but you will not have any credits. You will not get points. So do waste segregation on site. Put different boxes. Okay. And actually, in the real life, in projects, they will always, the waste hauler or the people who take the waste, the company, when you have big project, you make contract with them. and they will divide the waste into two types: organic and inorganic. Organic and inorganic. But even though they put inorganic waste or waste recyclables all together, you still need, if you want to take the LEED point, to put these boxes, 3 boxes or 5 boxes. These are the things to be recycled or waste streams to get points. If you want only prerequisite, okay, that's fine. Okay. So you need to decide is commingled or segregated. If commingled, you will not get the points. Take appropriate measures for the safe collection, storage, and disposal of the two of the following: batteries, mercury, and electronic waste. This we call it hazard waste or hazardous waste. That is toxic waste. Sometimes I told you this is hazard waste or electronic waste or hazard waste. So he told me, no, it's hazard waste. It's not electronic. It is the same. These are the types of waste. Electronic is hazard, okay, or toxic. Lamp containing mercury, this also hazard waste, okay. So I just giving you more details here about the waste, okay, just examples to get to your point. But depend on your activity. Maybe you are factory, chemicals or petrochemicals, some types of waste of this manufacturing is also hazard. So you need to know, I'm just giving here an examples for the common buildings. Like what you see here, this kind of waste. So you need to follow the standard way or make this so there are many solutions, of course, like some companies will take these products after end of use, or it will go to the right way to companies that will manage this waste, these types of waste. Okay, I will back to this credit again. One thing here, the waste area is from LEED AP, but you need to know, because sometimes in a LEED GA exam come, the waste area, it should be accessible with clear signage and easy access to the truck, the waste truck. This, of course, you know that, but you should know. And in safe area from safe and contained in one area specific for waste, and everyone knows this is the waste area, and there is access to the truck or access to the people who use it. The next credit is, this is also related to construction, but it's waste. So the waste during construction. The first one, it was operational waste, but this during construction. What are the strategies? As you know, construction waste, something like that, like what you see always, wood is the most or number one. So waste streams are different. It shouldn't be always glass, plastic, paper, metal, cardboard. No, depend on your business. So consider reducing waste by using modular construction. So consider here reducing waste. I will not reduce waste. So we will not here just go through it very quick. No, see, reduce waste by modular construction. So this waste generation and dealing with the waste itself, or waste reduction at the source. It is waste reduction at the source. So this is the concept or the secret we need to know here. The waste reduction at the source, it means I will not, before it become waste, I know I will do some strategies to reduce the waste through my design. Like some people doing paint above the concrete. The concrete is fair-faced, very nice, so they do painting. Reducing packaging, using modular construction. Why I should make one window is 1.1 meters, and the other one 1.05, and the other one is 1. Make it modular. Why? The work will be less waste coming out from the wood you cut. Okay, why should I make the door height to 220? No, make it 1 to 10, 1 to 20. Why? Make it all 220. Unify the widths of all the doors. Make it just 2 or 3 standard widths, standard height for all. Yeah. All this will reduce the waste. You reduce it by design. Using slip form or some kind of formworks will save a lot of waste, like what you see here in the picture. This way we call it, okay, waste reduction strategies on site during design and construction. In this credit, you need to prepare construction waste management plan. And this part, if you are working as contractor, you will prepare this plan, not the design consultant. Construction, how you manage waste during construction in cooperation with environmental team, site construction team, and the whole team, and sustainability team to know how to divert waste or how to reduce waste during construction, and the ways to divert construction waste. This after you have already, you become, there is waste, how you will deal with it, how you will divert it. Divert here means you take the waste, send to a facility that will reproduce this waste or recycle this waste. Okay? Or reuse this waste. Not just go to landfill. Landfill means go to waste. خلاص. Nobody will use. They will bury in the land. This means landfill. So what the plan should include? Construction waste management plan. And sometimes, you know, when I was working in my first LEED project, I went to the contractor as a consultant, and he asked me, he hired me as his consultant. So he told me, I want you to do for me CWMP. I said, what is CWMP? This is CWMP. Construction waste management plan. So in the plan, I have identified, based on site visit, the convenient storage place for recyclable. Recyclable means the material to be recycled. Then I decided which consider to be recycle or reuse or donate. Donation also is another way to reuse. But let's know what is the difference between recycle, reuse, donate. Anybody knows? Recycle means I give a chance for participation. What means recycle? What means reuse? What is the difference? Let's say recycle and reuse. What is the difference between recycle and reuse? I am on site. This is the waste in front of me. This will be recycled. That will be reused. That will be donating. I tell you, recycle means the waste you have can go to factory again, manufacturing, and they make it again new product. So recycling includes the process of manufacturing process. What about reuse? Reuse is different. Reuse, like I remove this door from here and it will go to be used as a door in another building. I will remove this table and furniture. I will take it another place where it will be the same table, the same chair, in the same color, nothing changed. So this reuse. Okay? Reuse. Donate is like you also donate, you give to some organizations where they can also reuse it or recycle it. You just give to them. They will make use of it. Okay? Sign a contract with hauler. Who is the hauler? The hauler is the truck that will come take the waste, and this is a contractor who will take your waste, and he have facility to recycle it, or just he do segregation, and the other contractors, factories will be this supply material to them. So you now participate in resupply of the material instead of coming from the virgin material from the land. No, it come from a waste that was a load on us on the earth. Okay. Consider waste to energy. Sometimes I already recycle, I reuse, I donate, but still some waste. Burn it. And even you burn it, you can use it for energy. So this is another way, accept it. But you don't burn immediately after you do recycle, reuse, donate. Okay? send it to energy or burn it. Waste to energy is conversion of non-recyclable. This cannot be recycled, so what I will do? I will burn it. Instead of sending to landfill, burn it and get some power. And also the output of burning these types of waste, it can be fly ash and can be added to concrete. So you are using everything. Yeah? Of course, contractors are many here. They are using. You will face the challenge if you are working in lease project. You will not find the waste hauler or some recycling data. This will be a challenge for all projects, so don't worry about it. The same challenge you face, the same everyone is facing, and the organization will understand this. We will, based on every project situation, the lead coordinator or sustainability, they will arrange. So I get many questions from my previous colleagues who take with me the course. We do not find the recycling facility in this. Okay, just do it. Just do the do this place for recycling your material, make design and so on, and others that you cannot out of your control. You cannot do anything, of course. Very important note. Excavated soil is not a recycling material. So don't put excavated soil as recycling. Land clearing debris, it's not. You cannot consider it as a part of recycling. Alternate daily cover is not considered construction waste. So it cannot be recycled. Someone will ask me, anybody know what is alternate daily cover? Alternate daily cover is a fabric material they put when they send material to landfill. They make excavation, but they will not let the waste open like this for animals and so on. No, they will just cover it. So they put the waste here and cover it by something like that. Construction waste management plan. You need to do also construction waste management plan. This one, construction waste management plan. Why? Because in the plan, it will highlight all the strategies you will do. Okay, any question before we move to the next? So waste in design or in operation, waste on construction, we cover. Now, building LCA, life cycle impact reduction, how to reduce the environmental impact of the building through the life cycle of the building. That is the meaning of this credit. But if you want to know the credit name is better, building life cycle impact reduction. What impact do you want to reduce? The environmental impact of our building. Okay, this is what you want to do. So LCA production option. First option, reuse. We already know reuse, this credit. The second option, first and second option, reuse. The first one is building reuse. The second one is material reuse. Material reuse. And the third is conducting LCA or life cycle analysis to demonstrate reduction in environmental impact. So the first one is building reuse. We have been working in a building that was in Australia, and it was a stadium with where a retaining wall, big retaining wall, we keep it. So this is a building reuse. But you will tell me, oh, it's a retaining wall. No, this is building reuse because it's a wall element or part building or part of the building. But material reuse, it's like I remove the door and I use it another way. This material reuse. I remove the let's say any building component that you can remove and fix somewhere else. This we call it material bricks. Bricks, I said bricks. Okay. Any element that you can take it clean and you can extract it, we call it salvage. We call it salvage. Extract it, take it clean, keep it clean and no damage with it, and take it. Ceiling panels. Okay, ceiling panels, I take it, there is no damage. Okay, I will take it, reuse it somewhere else. This material reuse. And instead of both, you can also do LCA. Everyone have point. If you want to take the 3 points, do both the 3. But you can conduct a life cycle analysis to demonstrate reduction in environmental. And this is usually done by third-party consultant specialist in LCA. So strategies, building reuse. There are two types, historic building or blighted buildings. What are historic, what are blighted? Historic building of historic value, you need to preserve, retain these buildings, of course. But blighted means all building, defined as neglected, run down, deteriorated, something like these buildings. Okay? They are blighted. Sorry, 1 second. يعني old buildings, delighted building, blighted means old, damaged. So you need to remove all the skin of the building and make again finishes, good finishes and so on. This blighted building. Rehabilitate the building. Okay, so you can use here like what you see in the picture for building reuse, remove the finishes, make new finishes. You may keep the structure element, interior non-structural element if they are like interior walls, doors, and floors, if they are good. You may, of course, you will keep the structure elements that like walls and ceiling and beams and so on. Don't reuse any hazardous or contaminated damaged part of the building. It's allowed for this credit for about 20% or more of the building to be removed. No issue. You still can take this credit. So it doesn't mean building reuse, I use every part. No, they will allow you for 25 or more, 25 to remove because it's already damaged like what you see here. So you need to just remove it. Material reuse is like you remove door and sell it in the market. Remove the bricks like what we see. And it's not necessarily in the same location. You may in the city of Riyadh and you send it to Jeddah or any other city. So this is the difference in the building reuse and material reuse. Same location, same purpose, but material reuse, different location, different purpose. The last option, when you send to consultant to make for you LCAs, will give you this result like this: life cycle analysis, investigation, and the evaluation, environmental impact or building throughout its lifespan. They always use software. This reference building, this proposed building. Proposed building is your building design. So you make analysis, LCA, and this reference. Always your proposed should be less in the 6 categories. You remember I told you LCA have 6 categories, which is global warming, acidification, eutrophication, so on. So your building should use should have less impact in every category. Here exceed. So here there is an action should be taken in the design. What cause more eutrophication? What material you are using, and so on. And LCA is not easy. It's about applying some concepts and knowledge to a simple software. Before they are not using software. Now there are softwares. And many companies give courses. One of the famous giving LCA is One Click LCA. I see it always in LinkedIn. It's a good company. And many people take courses there. It's not marketing for them, but I just give you a guidance. My advice, finish LEED GA, LEED AP first if you are willing to take more courses in green buildings. Building product disclosure and optimization. This is another credit. What means building product disclosure? The product will disclose. When you buy medicine, guys, for example, you find the pamphlet on site, inside the a paper which writes the side effect and so on. This is the product disclosure. In building material, we call it product disclosure and optimization, how to improve it. When you disclose something wrong, you always improve. So here in the LEED, they want you disclose. Understanding disclosure. There are 3 types of disclosure. Forget about this. APD, HPD, CSR. This is what I want you to know. What is APD? What is HPD? What is CSR? APD, environmental product declaration. You will declare environmental impact of your product. Why? It's EPD, environmental product declaration. That one. HPD, health product declaration. Like this product, during application of the product, you have healthy impact on the people working, the workers, and might be after installation also it have impact on the occupants of the buildings. So you need to declare the health impact of the product. CSR is disclosure for organizations like corporate sustainability report, where your organization declares their sustainability activities throughout the year. It can be quarter or half or every year. So disclosure part is assessed based on the number of products with disclosure from different manufacturers. يعني in LEED AP means in LEED AP we have credit called building product disclosure and optimization, and you know it now in LEED GA. What is disclosure? It's EPD, HPD, CSR. In LEED BD plus C, we will tell you percentage, let's say 20% or 20 suppliers should have 20 products from 5 different suppliers should have EPD or HPD or CSR, or should have declaration or disclosure. Yes, then you take point. So material department in your section has also need to specify this EPD, HPD, CSR. You have a challenge as consultant to put this specification inside your specs of materials. So a specification writer should know what is EPD, what is material disclosure, and what are the requirements of LEED, and implement it in project documentation, as because it might stay in the LEED reference guide forever. Even the project finished, they cannot do these credits. So you need specification writers now need to know very well about the material requirement and include it within the product specification or project specification and the other documents in the design. APD, environmental product declaration, we will declare again the 6 life cycle analysis products. Very easy. But very easy, APD is declaring environmental impact of the product. What are the environmental impact? You need to go to the life cycle analysis 6 categories and declare them. Declare the percentage of the total. Very easy. Next credit is sourcing of raw material or from where you bring your material. So they told you use materials from manufacturers who publish corporate sustainability report, and in LEED API I will tell you the requirement, which is 20 products from 5 or more suppliers should have CSR. A health product declaration is the same as EPD, but this focus on health impact, as you can see here down, if the product have any health impact. And these are all third-party certification. It's not like LEED. I told you LEED don't give certificate for product, but these types, they give certificate for product. HPD and EPD, these are specific certificates. Every manufacturer of any material try always to get as many as third-party certification to his product to be more used for different international projects. And you will find many products producers come to you and say to you, we are EPD, we have EPT, HPD, and so on. Okay. So the environmentally preferred product are products that have recycled content, bio-based material, like material from organic material, products that are harvested and processed and manufactured within 100 miles. Why? To reduce the transportation impacts through the greenhouse gases, and it should be FSC certified also. This we will speak so very soon. But before we speak, let's see what is recycled content. What is recycled content? Recycled content is a material you purchase like glass or bottle, and you'll find down the bottle the percentage recycled, 30% recycled, meaning there is in the material, virgin material 70 and 30% used from previous material, so it go to recycle. We have two types of recycled content, post-consumer and pre-consumer recycled content. Okay, so the post-consumer recycled content is, for example, you have used milk gallon or bottles and so on. It have been used, but pre-consumer, it's not used yet, but it's recycled also. It's a how. Let me give you example. If you are in factory manufacturing and you have, for example, a factory for wood and they cut wood, there is sawdust. Sawdust, this is a wood, sawdust is come from wood, and it's a waste that have never been used. It's a factory or fly ash. So they will take this waste, manufacturing waste, and they make from it MDF wood or something. Okay, so it never go to end user. But if you drink milk gallon, it's have gone to end user, and you drink it and you throw it in waste. So this is the difference between pre-consumer and post-consumer, but they are both recycled. Huh? So the recycled content always is the sum up of pre plus post. Yani like this. See here, post-consumer 37, pre-consumer 37. So the total is, I think 74% is the recycled content. Very easy. And we are using ISO 14021 for recycle reference as a reference standard. Bio-based material. What is bio-based material? In your design, always you are looking for alternatives to concrete and cement and steel. So as much as you can, at least for interiors, if you can use bamboo, cork, linoleum, white board, straw board, coir or jute, and all come from natural plants. This is bamboo, for example. Okay. And bamboo can go to manufacturing and they make floor, very modern, nice floor sheets and so on, all from bamboo. How to put this in your specification? You need to make research and find the suitable materials and so on. The wood used in our building in LEED, they need, but it's accredited, it's not a prerequisite, to be certified. Certified wood. What is certified and from where? Certified from Forest Stewardship Council. So you'll ask your supplier to have FSC certification. FSC certification, which is not difficult. Many suppliers have this certificate. What is FSC certification? It's certificate that indicates that this would come from a well-managed forest. See, this very important word. This is a badge, 100%. And of course, the owner of the forest which produce this type of wood have this certificate. So the supplier will bring it from a forest that have the FSC badge. If you want to know more about FSC, go to fsc.org. But you can search suppliers. Many suppliers now in the market can bring you FSC certified wood. Of course, it will not be from local. So this is another challenge, because maybe you look for FSC, you lose another point related to local material, or material come from 100 miles radius. So, but you cannot always win all. It's a win-win or win or lose. Okay, you need just to optimize the best for you. If you can get this wood, it's fine. If you cannot, not issue. Chain of custody. Chain of custody is a proof. You know, like the Forest Stewardship Council is like the car you buy, for example, and this like the ownership, the papers that you carry with you. Because this car you might purchase by many users, first user, second user, third users. So the wood stock, when it comes on the road, on the way, it might have supplier number one, supplier number two, and then it comes to you last to the project. So that's why we call it chain of custody certificate, where all people bring this wood from the forest, which have this wood, are signing in this forest COC certificate. Sometimes the forest itself will send you direct the wood chip by immediate, but they should also issue a COC certificate with the wood. Okay, it's like certificate of origin. When you buy product from China, you say certificate of origin. This product originated from where? You need it in importing some products. You say certificate of origin, where this product came from. The same for this certificate of origin, and sign anyone used or any supplier sell to other one, he will sign and give him the certificate with the product. We call it chain of custody certificate. Clear? So FSC and COC is clear. So if you are working in a company in procurement department, you will need to know this chapter very well. Purchasing policies you should put, you should use durable goods, and ongoing consumable, of course, you should put a policy for how to buy them, what are the preferred material, and so on. Last in this chapter is about green cleaning. We hear about green cleaning. Is it a green product or what? No, actually no. Green cleaning is refers to using cleaning methods and products with preferred environmental friendly ingredients and procedures. Why procedure? Because not only, anyway, green products or cleaning products are normally chemicals. So if you cannot manage the content by environmental friendly, which you will not find, at least the procedure, how to use it, the quantities. You need to preserve human health and the environmental quality, both when you do cleaning. Because sometimes you look to the building very clean, but when you live in it with these chemicals, you breathe it, especially if cleaning every day or every week, twice or three times, you will inhale it. It will impact your chest. So conventional cleaning product may contain bleach and ammonia. We know, of course, bleach and ammonia, and the other chemical that leave your home clean but pollute the air quality. Many ingredients found in house cleaners can cause eye irritation, skin irritation. It causes lung irritation and implication like contribution to cancer and more. So you need to train the cleaning staff. You need to select the preferred material or environmental material for cleaning that will not impact and cause any issues to the building occupant. This is the meaning of green cleaning. Points to remember for the material chapter. Material and resource credit, MAP materials are excluded from calculation. MAP materials are excluded. MAP, why? Because MAP material, if it's used within your building, it's against health and wellness to reuse it again, like wash basins, all these pipes and so on, wires. For health and safety, you cannot use it again. You can just, but you can recycle, yes, you can send to recycle, to send to back to factory, they make new product, but don't reuse, okay? Don't reuse. So they are excluded from calculation. Even they will be recycled, they are not excluded. Furniture, you can include it, but if you include it in all credits. So I prefer not to include furniture because this will be after operation and you don't know what furniture will be used. But if you are the owner and you will do everything, including furniture, you can put it if it will give you an advantage. Only permanent installed material are included, like scaffolding and other temporary construction materials are not included in our calculations. As a summary, you need to have storage of recyclables. This is a credit, prerequisite, construction waste management, building life cycle impact reduction, the three options, building product disclosure and optimization. What are the preferred materials? Very simple, but let's have some questions to clarify these things more better for you. Questions always is the best way, and by the way, the question is part of your study. Question is not to test yourself now. You will not test yourself now. These questions to help you further understand and complete your understanding of what in the slides. So slides plus questions I give you here are part of your study. Both you study the question and you study the slides. If you want more questions, you can have also some simulation exam. This you can buy it from other source, if from myself or from any other source, it's open to you. But this also very good point to, after every chapter, have more questions, more and so on. Okay, let's go to material and resource. We still have one class more, and I might give you another class to give you some simulation exam or something, like I answer with you some sample of this exam if you'd like. But if the next class is the next Saturday also, we can, it will be the end. I think since we have finished material and resources, we have time next class. So I'll give you next class. No need for to go for another week 8. So week 7, we can have the chapter indoor environmental quality, and we go to answer, give you some also discussions and the questions to answer together. Material and resources, how many here? Let's see. Only here's 15 questions, so we'll answer 7 questions or 8. Okay. Let's start question number 2. We'll go to, let's keep it 1 because you always answer 2. When selecting windows for a building, along with performance and adaptability, what else should the project team consider? Social, reusing old windows, leverage points, embodied energy of the window. Let's see your answers. I have one answer only. It's me. I know your answer will vary when I choose a window along with performance and adaptability. What else a project team should consider? Social context of the window, reusing old window, leverage point, embodied energy of the window. I believe it's a not social, not reusing old windows. Okay. Reusing, yes, when selecting window for what and along with performance. But here he's not selecting about he's not speaking about old or new. In general, either it's reused or new. In general, when you're selecting a windows, he don't say reused or either it's reused or new, because only reuse it doesn't make sense. So any window you select, either it's reused or new. So B, it doesn't make sense. Remove B. Don't make it confuse you. Social or leverage is not related. The embedded energy of the window. Why? The embedded energy is the energy you spend from the day you extract or you get the product until it reaches to your site, which is, we call it LCA. Good, good. You answer correct. Thank you. Very nice. Excellent. Always the courses, when it comes to concluded at the last 2 chapters, you find yourself already, your mind start to absorb info and connect it. You will find yourself already used to the way. That's why I tell you, for example, if you go practice simulation exams, I have, for example, 6 exams, 600 questions on the site. So some people complain to me, they say, oh, okay, first exam I failed, I get 50. I told them it's so normal. For what the exam? For you to learn from your mistakes. You fail, I give you the question, I give you the answer. I give you there, it's like simulated. So I give you the answer and why this is the right answer, why this is the, and I explain it to you here also in the course, because this company course, I explain you why is this correct, why is this wrong, we analyze the questions. So we are learning from the questions. Even myself, when I have new course, I always learn from the question. After studying, I'm still not able to answer the questions. After I answer 2-3 exams, I answer first all chapters and study the question of every chapter. Then I go simulation. First one and second one, I still used to adapt my mind how the way they ask the question. LEED is not like other courses, quality and other courses. LEED is very scientific. It make everything make logic, and you need to think it, to think about it, understand it First thing, you need to understand LEED and LEED concepts from myself. Once you understand, you can deal with any question also. And once you answer some simulations or practice questions, then you will be a master. You will find yourself after that in the last 2 exams or 2 or 3, then you can start to make time for yourself to start to answer without looking to the answer in every question. So that is the way you take it. Sometimes you can answer all the exams and look at the answers, understand what is the answer, and then go back next time to answer the same exam again. After you finish it, you get 60%. For example, you answer it second time, you will get 80%. Third time, you will get above 90. Then you are ready for the exam. Okay. So always, because I say this because some engineer comes disappointed. I failed the exam. That's normal. That's normal. Very normal. Okay. Question number 5. What are the biggest waste categories sent to landfill as a result of building operation in a commercial building? Here you need to be smart. I told you waste stream, glass, plastic, metal, cardboard, right? But in here, it will not be like this. It's a commercial building, guys, commercial. Huh? So mercury containing light bulbs. Choose 2, huh? Concrete. We will finish soon, only 5 minutes. Our time end up, but we'll finish just concrete. Organics, paper, aluminum can. Do you know that commercial building people always eat and drink? Yes or no? Yes. So see, they are eat and drink. So it is what? It's not paper. They are not in the office. Mercury, it's not mercury also. It's not only, it's mercury is normal. It's in the light bulb, yes, but it's not concrete because they will not really have concrete. It's a building in operation, so it's not during construction. It's not during construction. Okay, so it's not concrete. I told you, people in the commercial, in the malls, for example, what do? They eat and drink. Yes? What is the waste there in the mall? It's organics and aluminum cans. C and D. Yes, correct. Yes, correct. C and D. Yes. So answer C and E is correct. Paper, I will say. That's why, see, I will tell you the real situation in real projects. When we go and do waste strategy in the project, we do something. We do something. We name waste audit. Before I decide, in the lead, it tell you glass, plastic, metal, and so on. But it depends on your business type, also. But there are 5 in lead, the standard. In lead GA, you know this. But in the real life, and when you finish also lead BD, lead AB, the second level, we do waste audit. What waste audit? I will go to this mall and see what types or factory for manufacturing dress or clothes. Of course, I will find in the waste is clothes, and also what else? Any equipment related to clothes. So it will not. It's not glass. It's not plastic. It's not metal. So I will make waste stream name clothes, and how to recycle these clothes. Yes or no? Yeah. And of course there are many waste stream, not only clothes. But I will choose in this case 4 or 5. 4 or 5. And make the design required like 4 bins, 4 waste bins, and this for clothes, this for organic, this for what, this what. Okay. This for paper because this factory also using papers. So for paper, this for maybe they are using some plastic and glass also. You put there. Okay, yeah, but sometimes it will be different. But the standard case: glass, plastic, metal, corrugated cardboard. What else? I remember there are 5. Someone remind me. Paper, glass, plastic, metal. Paper, glass, plastic, metal, corrugated cardboard. This is 5. Okay. Question 7. What document?
Excuse me, sir. I think you forget about question number 3. What was the did we answer 3?
3, okay, no problem. We'll back to it. No problem, no issue.
Okay.
Okay. What document does the project team create for the administrative and procedural requirements for salvage, recycle, disposing of non-hazardous demolition and construction waste? Building life cycle plan, owner project requirement, construction waste management plan, building commissioning plan. Can you answer, please? Should answer this, all of you. Yes, exactly. All of you answered correct. Construction waste, CWMP. You remember when I told you I go to project, so CWMP. One of the contractor deliverables. Question 9. A project team is reviewing potential building materials for a school project. What impact would reusing bricks and stones found off-site have on triple bottom line? Choose 2. So here I'm using material reuse for the bricks and the stone, right? So what is the impact? B and D. B is the reuse would be cost effective. The reuse would be sustainable. Triple bottom line. The reuse would reduce peak energy demand. The reuse would be cost effective. The reuse would decrease energy performance. The reuse would take away local jobs. The reuse would be sustainable. Of course, reuse is sustainable. What else of the other 4? Peak energy demand, it's not related. The reuse can be cost effective. Yeah, it can be cost effective, but let's see the other C and D first. The reuse with decrease energy performance, it's not related. The reuse would take away local job, it's not related. So the answer is B and E. In these types of question, you need to read everyone and delete or exclude some points and see what is the most logic. What is the most logic? Okay, B and D. Number 11. A product with a healthy product declaration will assist the project team and select a product that meet which of the following criteria? Can be recycled, less negative health effects, are verified to have responsibly sourced, are more durable. Healthy product declaration, if I select it, it will help project team. Sorry, a product, the product that have HPD, a product. If the project team select this product, okay, it will meet the following criteria. Can be recycled, it's not related. Have less negative health impact, for sure. Are verified to have been responsibly sourced, not necessarily. Yes, So health about the health properties, not about from where you get the product. Are more durable? It doesn't matter. It can be durable and it cannot be. Okay, anyway, so the answer is like what you answer, have less negative health effect because it has HPD. 13, what is true regarding carpet made from recycled milk jugs? Let's have your answer. Lou Ann, please answer this. Are you there? Okay, let's have Ryan answer C in the chat box. What about all team? What is true regarding a carpet made from recycled milk jugs? This is a post-consumer. This is first. The carpet is more durable. No, the carpet has lower life cycle cost. I believe yes, it can be, but let's read the other. The carpet contain post-consumer. That's correct, of course, 100%. The material would reduce the need for virgin material. That is the most important. C and D. C and D. The material, because when I recycle, what is the most, the main reason why? To reduce the load on new material. New material. That's why I recycle. So C and D. Number last is 15. What is FSC certified wood? I would answer, let's have the last one in the list, Mr. Mohammed Idris. Okay, go ahead. So what is your answer? Or let's say Mr. Muhammad Javid. Okay, your answer. What is FSC certified wood? Wood that has been sourced, extracted, manufactured within 100 miles? This actually no. This is regional material. We call it regional material. Access certified within, or you get it within 100 miles. Regional material. Wood that has been produced from well-managed forest. Actually, yes. Why? I don't need to read others. Because also in the exam, if you find something you are very sure this is the answer, no need to read others because you're wasting your time. If you remember, I opened to you the, see, I will show you something very interesting. The answer here. Where is the FSC? You remember the FSC? Here. See? See this one? See this badge? Can you see the screen? See this badge? See what is written here? From well-managed forests. I put the cursor the green. From well-managed forest. So that's why wood that has been come from well-managed forest. This is the answer. This is the answer from well-managed wood that had come from well-managed forest. That is the right answer. Back to 3 that we passed. We forgot 3. 3 we say a floor covering that can be recycled into new product at the end of its useful life would be what of type? The floor cover can be recycled at the end of its life. Okay, what it would be type of product? It can be recycled, so it could be passive, cradle to grave, cradle to cradle, renewable. Yeah, we always at the end of life, we need to not send to landfill. We don't want to send to landfill. What is landfill? Like go and purify it, bury it in the land. Even you will not burn it and get energy, you will not reduce, you will not recycle. So it's become open end, not closed in. Closed in means I will go and go another process, so it will be something like what you answer here. CC, excellent. Cradle to cradle. That is the right answer, cradle to cradle. Well, I wish this class was interesting. I know because material is very common to anyone who always think is before that sustainability is material, reduce, recycle, reuse, but it's only part of the many parts to measure. Thank you very much. And now time for your questions. I'll give you any questions you have. No further questions. Okay, so keep also if you have question for the next class. Thank you. Thank you very much. See you all next Saturday.